Learning objectives. At the end of this topic, you will be able to explain the sources of alternative or non-conventional sources of energy, discuss the environmental consequences, differentiate renewable and non-renewable sources of energy. Introduction. Rita and her friend Sheila.
I heard about non-conventional sources of energy. Can you tell me more about it? Sure. Let me tell you more about it in this chapter.
Introduction. With technological progress, our demand for energy increases day by day. As our demand for energy increases, we need to look for more and more sources of energy. We could develop the technology to use the available or known sources of energy more efficiently and also look to new sources of energy. Any new source of energy we seek to exploit would need specific devices developed with that source in mind. We shall now look at some of the latest sources of energy that we seek to tap and the technology designed to capture and store energy from that source. Non-conventional sources of energy, solar energy. We know that the sun has been radiating an enormous amount of energy at the present rate for nearly 5 billion years and will continue radiating at that rate for about 5 billion years more. Only a small part of solar energy reaches the outer layer of the Earth's atmosphere. Nearly half of it is absorbed while passing through the atmosphere and the rest reaches the Earth's surface. A black surface absorbs more heat as compared to a white or a reflecting surface under identical conditions. Solar cookers and solar water heaters use this property in their working. Some solar cookers achieve a higher temperature by using mirrors to focus the rays of the sun. Solar cookers are covered with a glass plate. It is easy to see that these devices are useful only at certain times during the day. This limitation of using solar energy is overcome by using solar cells that convert solar energy into electricity. A typical cell develops a voltage of 0.5 to 1 volt and can produce about 0.7 watts of electricity when exposed to the sun. A large number of solar cells are combined in an arrangement called the solar cell panel that can deliver enough electricity for practical use. The principal advantages associated with solar cells are that they have no moving parts, require little maintenance, and work quite satisfactorily without the use of any focusing device. Another advantage is that they can be set up in remote and inaccessible hamlets or very sparsely inhabited areas in which laying of a power transmission line may be expensive and not commercially viable. Silicon, which is used for making solar cells, is abundant in nature, but availability of the special grade silicon for making solar cells is limited. The entire process of manufacture is still very expensive. Silver used for interconnection of the cells in the panel further adds to the cost. In spite of the high cost and low efficiency, solar cells are used for many scientific and technological applications. Let's discuss about tidal energy. Due to the gravitational pull of mainly the moon on the spinning earth, the level of water in the sea rises and falls. If you live near the sea or ever travel to some place near the sea, try and observe how the sea level changes during the day. This phenomenon is called high and low tides, and the difference in sea levels gives us tidal energy. Tidal energy is harnessed by constructing a dam across a narrow opening to the sea. A turbine fixed to the opening of the dam converts tidal energy to electricity. Let's discuss about wave energy. The kinetic energy possessed by huge waves near the seashore can be trapped in a similar manner to generate electricity. The waves are generated by strong winds blowing across the sea. Wave energy would be a viable proposition only where waves are very strong. A wide variety of devices have been developed to trap wave energy for rotation of turbine and production of electricity. Let's discuss about ocean thermal energy. The water at the surface of the sea or ocean is heated by the sun, while the water in deeper sections is relatively cold. This difference in temperature is exploited to obtain energy in ocean thermal energy conversion plants. These plants can operate if the temperature difference between the water at the surface and water at depths up to 2 kilometers is 20 Kelvin, 20 degrees Celsius, or more. The warm surface water is used to boil a volatile liquid like ammonia. The vapors of the liquid are then used to run the turbine of the generator. The cold water from the depth of the ocean is pumped up and condensed vapor again to liquid. The energy potential from the sea, tidal energy, wave energy, and ocean thermal energy is quite large, but efficient commercial exploitation is difficult. Let's discuss about geothermal energy. Due to geological changes, molten rocks formed in the deeper hot regions of the Earth's crust are pushed upwards and trapped in certain regions called the hot spots. When underground water comes in contact with a hot spot, steam is generated. Sometimes, hot water from that region finds outlets at the surface. Such outlets are known as hot springs. The steam trapped in rocks is routed through a pipe to a turbine and used to generate electricity. Let's know how nuclear energy is produced. In a process called the nuclear fission, the nucleus of a heavy atom such as uranium, plutonium, or thorium, when bombarded with low-energy neutrons, can be split apart into lighter nuclei. When this is done, a tremendous amount of energy is released if the mass of the original nucleus is just a little more than the sum of the masses of the individual products. The fission of an atom of uranium, for example, produces 10 million times the energy produced by the combustion of an atom of carbon from coal. In a nuclear reactor designed for electric power generation, such nuclear fuel can be part of a self-sustaining fission chain reaction that releases energy at a controlled rate. The released energy can be used to produce steam and further generate electricity. The major hazard of nuclear power generation is the storage and disposal of spent or used fuels. The uranium still decaying into harmful subatomic particles, radiations. Improper nuclear waste storage and disposal results in environmental contamination. Further, there is a risk of accidental leakage of nuclear radiation. Environmental consequences. Exploiting any source of energy disturbs the environment in some way or the other. In any given situation, the source we would choose depends upon the factors such as the ease of extracting energy from that source, the economics of extracting energy from the source, the efficiency of the technology available, and the environmental damage that will be caused by using that source. Though we talk of clean fuels like the CNG, it would be more exact to say that a particular source is cleaner than the other. We've already seen that burning fossil fuels causes air pollution. In some cases, the actual operation of a device like the solar cell may be pollution-free, but the assembly of the device would have caused some environmental damage. How long will an energy source last us? We saw earlier that we cannot depend on the fossil fuels for much longer. Such sources that will get depleted someday are said to be exhaustible sources or non-renewable sources of energy. On the other hand, if we manage biomass by replacing the trees we cut down for firewood, we can be assured of a constant supply of energy at a particular rate. Such energy sources that can be regenerated are called renewable sources of energy. Renewable energy is available in our natural environment in the form of some continuing or repetitive currents of energy, or is stored in such large underground reservoirs that the rate of depletion of the reservoir because of extraction of usable energy is practically negligible. Summary. Let's summarize the topic. Our demand for energy has been increasing day by day with technological progress. Solar cookers attain a higher temperature with the help of mirrors to focus the rays of the sun. The kinetic energy possessed by huge waves near the seashore can be trapped to generate electricity. The steam trapped in rocks is routed through a pipe to a turbine and used to generate electricity.